Hello, Danielle. Hello, Sarah.
Hello.
How's you doing there?
Doing okay. How are you doing?
I'm doing fine. We're excited about September Power BI meetings, and we're just waiting a few minutes in case somebody want to join us.
Sounds good.
So, do you think I have to go and start?
I think to, make sure that we're not going over Sarah and Danielle's time, that we can go ahead and start, yeah.
Okay. Hello, everyone. It's the September Power BI and Fabric meeting, and today we'll start our presentation with here. Oh, sorry. Okay. The agenda will go over introduce the leader and some introduction, what happens in the Fabric and Power BI, some update about both of them. And then we move up to the main talk for today. We'll introduce some question. So the bug leaders, which is Lawrence and Ryan, me, which I'm a data scientist. I'm interested in all kind of data processing, from data scientist to data engineering to data analysis to AI. And Jason, which is not with us today too, and Antonio Ramsey, which is the speaker for us today for this meeting, and Chris Alban. And Antonio, do you want to introduce yourself before we move on?
Sure. My name is Antonio Ramsey. I'm with the San Antonio Water System. I'm the Director of Internal Audit. And within the group of internal audit, I focus on IT audits and data analytics.
Thank you, Antonio. You can find the group in Meetup, in LinkedIn, and you can, if you're interested in LinkedIn Tree, there's a lot of information. You can get it from all website about Power BI and Fabric, and there is the community or Fabric. It's increasing, and that's why it's interesting to expand the Power BI group to include Fabric too. So, well, yeah, I think about Power BI relating this session usually in the last Wednesday from each month at lunchtime. So bring your lunch with you. I brought my coffee. Based on the, we made some, a few months ago, we made some what people think about our interest in this group, and we come up with this list that mostly Power BI, some DAX, data visualization, Fabric. So if you're looking for something else, please let us know. So we're open to all kind of idea and presentation and talks. For the Fabric update, so I will go for a few of the Fabric update, and if you're interested to go deeper of that, check the website and you just link it. So most of the update will be about the Apache Spark, which it's been updated by collecting the logs and the metrics. This new feature will allow the Apache Spark user to collect the Spark logs, job events, metrics from all the Spark application and send it to the various destination. It's very efficient and helpful aspect from the Spark in order to diagnose all the steps you have it. And the announcing the public review or TSQL notebook in the Fabric. This update will expand the language offering, allowing the TSQL developer to use notebooks for data warehouse development. Notebook using is very useful and make your life much easier. So this new thing in TSQL is very useful. You can manage complex query document during your process with markdown cells and so you do your process, then you document what you do. So if you come back after a year, you can understand what you did. So, and the notebook is very useful tools to do that. Organizing your table with Lakehouse schema and more public view. This feature lets users arrange their Lakehouse table into folder like structure, enhancing data discovery and more of that. Regarding the Power BI updates, so the dark mode is now available for Power BI desktop, which sometimes I found it's very nice to have this black mode in it. So it enhances this the vision sometimes. Update menu bar in the surface view mode, visual calculation update, visual where we can the visual calculation and now or by default, so you can start using them right away without having to enable the preview feature. And the visual level format string. So the visual level format string allow you to format the field and the measures on the visual and like scaling up with it, which you think it's a small thing, but in the real work, it takes some time to make the scaling. Multiple org apps per workspace, costume color too, and subscribe to the report of both the Power BI and the Fabric if you're interested in following up or what's going on, because there's always more and more happening in both domains. And now we'll move to the today's talk, which is introducing the CRISP-DM framework by Antonio Ramsey, and it's with you, Antonio. I'll stop sharing. Okay.
All right, and let me know. Are you able to see my screen?
Yes, we can see
yours.
Awesome, thank you. Thank you so much for the introduction. As Ryan said, I will be presenting today on the CRISP-DM framework, and I'd kind of already introduced myself earlier. So to kind of give you an agenda of what we'll be covering today, first we're going to be looking at an introduction of what the CRISP-DM framework is, how it kind of came about, and some of the things why it makes it a good framework for data science projects to follow. We'll then look into a deeper dive into the actual phases within the framework, and then kind of wrap with a summary and some QA and comments if anybody or any questions that people may have. Some of the objectives I'm hoping is so that people can kind of get an understanding of what the methodology with the CRISP-DM is, recognize some of the benefits and the flexibility that CRISP-DM allows you to take advantage of when you roll it out and use it in a project, and then identify some of the applications that you can use it for when you're going through. So to kind of give you an understanding, CRISP-DM stands for Cross-Industry Standard Process for Data Mining. This was developed in the late 90s by a consortium of different companies. At that time, there wasn't a set standard that a lot of companies were using when they were looking at data mining or data science projects at that time. So several of them came together. Some of them were SPSS, which is now part of IBM, NCR, Daimler-Benz. And the goal was to standardize these data mining projects and processes across industries so that there could be one framework, no matter the industry you're in, that everybody can use. The first version of CRISP-DM was rolled out and introduced in 1999 and quickly gained popularity because of that flexibility and the robust guidance that it provides. Since its release, Christium has been widely adopted across the community and is a tried and true structure for both novice and seasoned data professionals. To kind of get some of the advantages of Christium and what makes it so flexible and stuff is that it is non-proprietary, meaning that no one actually owns this. It's just, as I said, those consortiums came together. They produced this framework and published it for basically open source to manage it. Because it's not owned, it's accessible to anyone. You don't have to have, a product. You don't have to buy anything for that. And it just provides a structured approach to help ensure successful project outcomes. In addition to not only not being proprietary, it's a neutral framework, meaning that it aligns with a natural framework that aligns with the data science life cycle. This cycle is broken up in Christium into 6 phases, from the business understanding to acquiring and prepping your data to modeling, evaluation, and deployment. It's just a logical progression that helps projects, teams avoid confusion and stay focused as they're moving through the actual data science project. In addition, this is where I was talking about, to not only being non-proprietary, that it is a neutral product or framework, I should say. So again, it is across all industries, so it can be utilized in finance, healthcare, manufacturing with few or no modifications to the actual framework that is, published. And then in addition to it, it's not tool specific. So it's all about basically taking that business problem that you're trying to solve, the data that you have, and then utilizing the tools that either you have access to or that are going to best suit the tools that are going to utilize that data to help you solve that problem. So it's not going to say, hey, you need to use Python for this, or this cloud platform or anything. It's just what you have at hand, and you can adopt it based on your available stack and the data. In addition, in the process itself, it is very hierarchical, which each phase, so there's 6 phases that we'll look at, break into generic task and specific tasks, allowing for detailed planning and execution of the project as you go through. At the higher levels, they're broad phases phases with subtasks under each one. And what's great about this is while you first look at it, it looks like it's very detailed, which it is detailed, but it's very like hard and fast that you can't change it. However, you can make a lot of adaptability for your world implementation of this, and for the complex challenges that your team may face. A great example is, as I stated, I work in the internal audit group. Well, obviously, we address projects slightly different than maybe the IT group would. So we can make changes to the Christium framework that align with our processes and our practices, instead of, how someone else in another department within SAWS might address them. So to kind of give you that overview of what the Christium framework looks like, as I did state, it breaks it into 6 phases throughout the life cycle. First, you have the business understanding phase, which is the first phase that focuses on defining the business objective and what you're trying to achieve with this project that you're taking on. Next, after that, you'll move into the data understanding phase. Again, this is a phase where you're just initially going to get data, start exploring it, and basically find trends and maybe defects within the data, anomalies, anything like that. After that, you would go into your prepping your data. Again, this is often a time-consuming process, but you're going to go through and clean the data and prepare it for modeling. Next would be modeling. And again, within that, you can utilize any model, any application or anything like that you see fit based on how you've prepped your data. Finally, is going to be your evaluation. So after you've modeled your data and you have your results, you will then move into evaluating that model and the results to determine at the beginning, where we've defined what our business objective is from the business understanding, does the project really align with that? Or do we need to go back and kind of make adjustments? Finally, after you've done your evaluation, you're going to do a deployment. And as we get into we're going to dive a little bit into each of these steps a little bit further. On the deployment, you can determine whether, hey, do we just need a report and that's all we need, or do we actually need to deploy out, this model into the operations environment, create a dashboard? How do we want to look at that? So to kind of look at this real quick in a little bit more detail, as we move through this cycle from business understanding to data understanding, that is an iterative process. So you'll start out with that business understanding, again, trying to understand what the business is asking of this project. Then you'll go into your data understanding, looking at the data that they have. And sometimes when you go into the data and you find trends or something like that, you may need to go back to the business to say, hey, we talked about XYZ, but I'm seeing something different in the data. And so you can have that iterative process back and forth. Once you get it comfortable that the data that you have and you have an understanding of it will basically help you answer that business problem that you're posing in the business understanding, then you'll go into preparation of your data, again, transforming it, cleaning it, readying it for the model that you're going to use. Again, once you go into modeling, there is an iterative process that can occur between data preparation and modeling, because maybe you've prepped it in one way, it's gone into the model, it doesn't look appropriate, right? So you may need to go back to prep the model, the data in a different way to utilize that model again, or you may need another modeling. So again, depending on the model you use, maybe data needs to be prepped, X way for model 1 and Y way for model 2. So again, that is an iterative. Again, after we said, after the modeling, go to evaluation. And that does go back up, as I stated, to the business understanding to make sure that you're answering and really meeting what the business is asking you in this project. And then after you've validated your evaluation, you do move that to deployment. The other thing, beyond just these iterative processes, the whole cycle itself is iterative, especially if in deployment you're rolling out the model into operations. There's going to be maintenance and management of that model that you're going to have. And so you'll go through this cycle repetitively in an iterative process to make sure that everything is maintaining on track to meet that business objective from what's been deployed. As I had kind of talked earlier, there is like a hierarchical structure. So it is structured with 4 levels. As you move from the phase level, which is the phase level 1, down to the process level, which is level 4, they go from more abstract to more specific actions that you have to take. So at the phase level, which is the top, the process is divided into those phases that we talked about, business understanding, data preparation. And in this, we're just basically trying to understand the step that we need to take. When we move into the next level 2, which is the generic task, each phase consists of several tasks. These tasks are designed so that the project, regardless of the specific injury, can be done in that way. And the key here is that the task covers the entire process of that phase. For example, one task might be cleaning the data within the data preparation, which is a broad task, and you can do that in any project. When you go down to level 3, which is the specialized task, this explains how the generic task should be carried out. So like I said, the generic one is that, hey, we're going to do this. When we get down to the specific, it's like how we're going to do this. For example, as we talked about in the generic is like cleaning the data. Well, in this task, we're going to say, we're going to describe how we're going to clean numeric values, categorical values, how this is going to differ, whether we're using a model where we want to look at clustering or, predictive modeling. And so we're going to basically be more specific from that generic of how the data is actually going to get cleaned. And at the process level, or level 4, finally, we're basically wanting to record the specific actions, decisions, and results of what we actually did at those higher tasks and levels and everything, and how that moves through. So as I stated earlier, that this starts with the business understanding phase, and it really sets the foundation of the entire project. This involves a deep dive understanding into the project objectives, requirements, and the business perspectives. Some of the things that we're going to do is we're going to state that statement of business objectives. So this is converting the goals into the project itself and like how they're going to go from what they want to achieve into an analytics question. So then once we kind of get their objective, we then get that statement of how this is going to translate into an analytics or data science objective. And then finally, we're going to outline what the statement of success or criteria looks like. So as we talked earlier, that there's the phase, which is level 1, and then you have your tasks, and then each task has outputs. So in this one, under business understanding, we have 4 tasks, which is to determine the business objective, assess the situation, determine the analytics or the data science goals, and then determine the business objectives. So again, with that determining at the first level, what you're going to want to do is get that background, meet with the stakeholders, and kind of get an understanding and a clear statement of what they're trying to achieve, such as like an example, we want to increase customer retention by 10% or optimize inventory management. We need something that must be measurable and align with the company's broader strategy. So that's where we're trying to get that determination of what their objective is. On the next level, where we're taking and trying to formulate that a business objective into an analytics, once we get that, we're trying to determine how we translate that into something that the team can actually use data and build out a model for. For example, we want to build a model to predict which customers are likely to churn within the next 3 months. So then that's transitioning, in how we have the objective of what they're trying to do into something that we can build a model for and actually make those predictive tests for. Again, after that, we want to then say, what does success look like? And everything. So next, we're going to say, hey, if the model that we build out is at least 85%, has 85% accuracy on this and stuff, that's what we're going to say success looks like for this project. All right. So after the business understanding, the next one is the data understanding. So in the data understanding, again, in this is the initial collection of data. Our goal here is to gather the data, and to familiarize ourselves with it. This involves going through and just again finding where the data that we're going to use specifically for this project is stored at, then pulling it in and doing exploratory analysis, trying to find common trends, maybe find relationship variables, and just verify the quality of the data as a whole. Additionally, maybe we're going to look for outliers that we may need to address. So when we go into the phases and stuff and tasks, in this phase, our task is the initial collection. And in some of this on the data understanding, we are going to have outputs, which we're going to have reports that that Chris DM recommends that you write or have documentation of. So you'll have initial collection and the collection of the initial data report. And what that is basically saying, hey, what server or what location did you get this from and how did you get the data? You're going to have a describe the data report. So in this report, it's just like, this is what it is, structured, unstructured, and just kind of go into that level of what we're looking at, how many rows, how many columns, all that. And then you're going to do some exploratory analysis of the data. What are you seeing? Again, looking at, are there anomalies? Are there correlations with the data that you're seeing? Anything along those lines that you would want to pull out that could be helpful in understanding how this data goes to the business objective and goes back to the analytics that we're trying to use to solve the business objective, or again, so that you can go back and have that conversation with the business saying, hey, this doesn't always align, or I'm seeing something else. And then finally, you want to verify that the data is complete, it's not missing any values, and the data is consistent across all of the different sources if you are pulling from different sources. One thing that I found when we've incorporated this that we found useful, and instead of having all those multiple reports, is that we've used exploratory data analysis reports. Basically, it's an approach that we've done with Python and some other platforms where we take the data set and we summarize its main characters through visual methods or reports and stuff. So we take the data, we plug it in. One of the ones that we utilize is Pandas profiling with Python, and it gets you an HTML report where it takes the whole data. It tells you, information about how many rows, how many columns on each column type. Is it categorical, numerical, and then max mins. How many missing data points do you have within that column? How is it complete? Is it all unique? Is there high cardinality? It gives you a lot of insight so that, again, you have that documentation of what the data looks like. So again, if this is a framework that you guys are looking at maybe exploring, and when you get to this, I would definitely recommend looking at utilizing EDAs to kind of make your life a little easier when you are doing the data understanding. After you have that data understanding process in place, the next one is the data preparation. So in the prep, one, you always got to think that this is going to be the majority of the project's time. They say what I've read is that data preparation is 90% of your project's time. In the data preparation piece, you're trying to basically prepare the data so that it can be put into that model. And it's crucial that the raw data is structured and in a place for the model that you're specifically wanting to. So you want to do the assessments to make sure that, again, from what you're understanding, your data understanding is that the quality aligns, you take care of any outliers, take care of any missing data, can take care of any inconsistencies, and then also just transform it as needed. If you need to do ETLs from your raw data into a certain area where you're going to be pulling data into the model, you do that at this point. So to kind of look at the tasks, again, we have starting from the phase, the data preparation. Again, we're selecting our data on that. And what this is to decide on what we're actually going to be utilizing in the data. Next, we're going to clean that data. As I stated, we kind of already have an understanding of what quality we're looking at from the prior phase, the data understanding. So we're going to understand how we're going to take care of those issues that we found in the quality. Next, we're going to construct the data. And in this phase, we're going to basically have a preparation of an outcome of new data derived out of our construction. And then we're going to integrate data. So where necessary, we're going to combine tables, records, anything like that. And then we're going to finally format it into a format that the tool can utilize if need be. And then kind of how I split it here, the reason why is that while we have these tasks and the outcomes for that, the ultimate outcomes for the data preparation is that you have the data set and a description of the data set that you're actually going to be putting into the model to be utilized. So again, after we have the data preparation done, the next piece is moving into the modeling phase. Here's where we're going to be selecting and applying various modeling techniques that are going to be utilized during this analytics or data science project. We can transition from preparing the data to building the model and everything by basically ensuring that we've set it up properly in that data preparation phase. Again, that's why it's so important that we spend the time there, is that if you don't have the data prepped right for the model you're going to be utilizing, you're going to have a lot of iterations back and forth and maybe not bad outcomes with your model. So in the modeling phase, we have 4 tasks. So we're going to first select the modeling technique we're going to use. So again, when we've gone through the prior phases, we kind of already, from the business understanding phase, there is a step where you kind of already have a kind of predetermined idea of what tools and techniques you're going to use. So once you get to this phase, you have either cemented what you've kind of set up earlier, or maybe as you've gone through your data preparation, you said, no, I want to change it, but you're going to have your final modeling selected. You're going to generate your test designed. So that's maybe you're going to utilize machine learning. So you design that out. How much are you going to put for your testing data versus how much you're going to leave on your training data. And then also you'll build out your model, define the parameter settings and the description of it, and then finally assess the model and basically look to determine, hey, this is the results we're kind of getting, and determine whether that is going to align with what you're wanting, or do we need to go back and take a step back to data preparation, and we need for more refinement and improvement so that we can, within the data preparation, so that when we pull it into the data model, that it's creating the model in a more precise way. Or, as I did say, maybe you're going to run several models. So you run your first model, and then you will need to maybe step back to your data preparation again, because the second model is going to be in a different way, and so you need to prepare the data. So there, as I did state, that's another part where you do have some iteration back and forth. The next phase is that data evaluation, or excuse me, the evaluation phase. Within the evaluation phase, we're going to thoroughly assess the model and review all steps taken at this point in order to, from a technical aspect, to make sure that it's meeting the business's objectives. This is a critical stage because this ensures that the results of our project are aligned with the business's goals and everything. So as we had showed earlier, not only are we looking at the model and the results of that and making sure that it technically aligns, but then we're going to go all the way back up to the business understanding and say, this is, what the business objective is. Is this model and the results from it meeting that overall objective of what they asked us for? So in this evaluation, we're going to evaluate the results, and we're going to basically determine how well the model meets the business objective. We'll check to see if if business reasons why the model may not, if there's business reasons why the model may not fully meet their objective, or was their data, not done in a proper, cleaned up in a proper way or adjusted in a proper way. We also then review the process, which is basically to ensure that the project process is fully captured and understood, and that there aren't any, there's not any important factors or tasks that we overlooked during the prior steps that could skew the model itself. Like a key question is, did we correctly build the model, or were the appropriate techniques and methods that we used correct, and everything. And then we'll finally determine the next steps after we've kind of done this. So we'll have a list of possible actions that we may take. So again, as we're moving into deployment, how is that going to look with the model and it's going back to the business and into operations? And then we'll move into deployment after we've made those critical steps. So as I stated, deployment is the last phase. This is where the insights that we've gained are organized and presented to the stakeholders in a way that they can use and apply to their business. Again, you have to be mindful of when you're bringing back these evaluations and results of the model and what you've done, that they align with that individual stakeholder's abilities. So if they're super technical, then you can be at that level. If maybe they're non-technical people, then you have to do presentations and stuff, and present either a report or a presentation in a way that the non-technical person can really understand how this can be utilized. Excuse me. Also, you need to determine how often this is going to be needed. So maybe this one time it was an ad hoc project that you need to do, or is this something that you're going to be needing to set up and do maybe on a quarterly basis for the business? So these are also things, not only, who's going to need it and how they're going to utilize it, but how often. So in the deployment phase, the task that we're going to do is the planned deployment. So we're going to basically develop a deployment plan, and this is how the results will be deployed to the business. And we're also going to do any documentation for the procedures so that, let's say that the business is going to, this is going to be deployed to the business, the model, and that they're going to maintain it and run it after we're done with the project. So we'll want to document all our procedures up to this point of how we've acquired the data, cleaned it, prepped it, built the model, and evaluated it. In addition, after we've created that planned deployment, again, if this is something that isn't a one-off, that this is going to be utilized over time, then there is working with the day-to-day business that is going to be handling this. So it may be something with IT or another group where we're basically going to determine how to create a monitoring and maintenance plan. So how often is it going to be evaluated against new data sources to make sure that there's no model drift occurring. If there is, anything that is noticed as drifting, how will maintenance be performed in addition to that? And again, one of the things that we'll have is that, let's say at the planned deployment phase that you determine that, hey, really they don't need a dashboard, they don't need access to the model. Really, at the end of the day, all they need is a final report that summarizes what we found or a presentation. So you may find that at those planned deployment and maintenance that you won't have to develop those out. It will really just be producing a final product report, or it could be that final product report on top of those two things that you need to develop. Finally, in the review the projects steps, is where basically that's more internally for us. This is where we review a project as a whole, involve what went right, what went wrong, how we can improve things, and then look at technical aspects of the project, as well as how management of the project went, and just conduct a thorough review from an internal perspective so that we can carry that forward into future projects, or we can give feedback to the business unit if they've taken ownership of it and that there needs to be anything done in the future. So to kind of give you a summary on, CRIST, it is a uniform structured framework for executing data science projects. It's both, as I stated, reliable and repeatable because it has specific tasks and phases and tasks and everything that guides you through each step. You can maintain basically that reliability and repeatability of the project itself. So if the business wants you to come back and do it again, then you already have the outline of how you've done it the first time. In addition, as I stated earlier, because it's neutral to industry, it's neutral to tools and everything, that there is a lot of flexibility itself. As I stated, there was, on data understanding, there's 4 steps on all those reports. Well, it isn't a hard and fast that you have to do all 4 reports as long as you're kind of doing the oversight of what they're trying to get you at, which is to understand your data. So again, you have a flexibility where you can kind of tweak some of the steps, the tasks under some of the phases as well. And like I said, it just allows you a guided documentation of your projects for repeatability, and making sure that if you're ever questioned about the reliability of your project, that again, you have it well documented. Is there any questions or anything that anyone has at this time?
Presentation looked great. Thank you for sharing that.
You're welcome. And I'll provide it to Rayon and you guys, because I think Lawrence usually emails it out, correct?
Yep. Thank you, Antonio, for great presentation. I have one question. So in the platform, these steps connecting to each other. So if I make change in one step, for example, if I change something in my feature or my input, can do automatic rerun to make the model or the deployment, or I have to go rerun each step by itself? Is there automatic connection between the 7 steps?
So it depends on what step you're going back to, as I did state that there's some steps that have iteration among with each other. So let's say that if you're talking about the modeling, that if you're in the modeling step phase 4, and you're finding that maybe your data wasn't prepped correctly, so then you could go back to 3 and then just prep your data. But if you're finding that there's maybe anomalies that you didn't see in the data understanding, then yes, you could you may have to go all the way back to phase
So
2.
Based on this figure, so I can go between 3 and 4 and 1 and 2.
That there's some natural iteration just because as I stated, like when you're first understanding what the business is asking you, that they may not have a clear understanding of what data they're producing or what it looks like. So as you're going through and understanding the data, you may have questions to go back to them and re-scope, the objective of it, or change up the analytics question and stuff. So that's a natural transgression, iteration there. The other thing that I've actually done is I like to try to get data ahead of time. So if I'm going into a project and I know that we're going to utilize, say for example, work order data at SAWS, I'm going to get access to the work order data, and I'm going to start already doing some of that data understanding, so that when I come into that initial business understanding meetings, that I already kind of have an idea of how the data is flowing or what I'm seeing to match up to their processes and what they're asking for it, so that there's already better questions being asked there. Again, I make that flexible thing to kind of put, phase 2 ahead or in combination with phase 1. And that's why I do like kind of this framework, is that it isn't just a hard fast that no, you have to do phase 1 then phase 2, that you're able to kind of change it. In addition to it, if you are interested in exploring it more, is that there has been a lot of groups, like I know healthcare sector, that they've actually created a CRISP-DM for healthcare specific data. With machine learning and AI becoming popular, that they've created a CRISP-DM machine learning framework, again, that's specific to that. And so that there have been some groups that are taking the basis of CRISP and kind of tweaking it to kind of align with some other industry, more specific things that are occurring.
Okay, that's very interesting. Yeah, like tweaking the platform for your special industry. Yep, it's get you a lot of benefits from that. So, and yeah, is there any other question?
I have a question. You said this is the framework itself is like an open source framework. Is there like a particular association or body that like maintains it, or?
So there is not a certain. I'll go back. So as I kind of stated in the beginning, that SPSS had initially kind of associated with it, and because they've been acquired, several times, and now they're under IBM. IBM does incorporate the CRISP into, and like if you go search for like any documents on it, it's going to direct you to an IBM website. But no one is, and I would say that's kind of one of the drawbacks, is that there hasn't been a direct consortium coming back together and updating this. It's been groups or individuals going and saying, hey, we need to make this update or change because this was in 1999 and big data has changed in this way, and maybe this doesn't really address the framework. This framework doesn't address the situation specifically. So that is the drawback, that it's open source, and that it's really not owned by anyone. Like I said, it's a lot of the documentation goes back to IBM, and I think it's and then if you do use the SPSS software, within that software, the steps are in there where you can actually document within the software. But like I said, the actual documentation, there's a PDF that you can get, and it's like I think 80 pages long, that walks you through all this information. that's just out there. So
Okay, thank you.
no problem. And actually, let me, before I send that over to you, Rayon, let me add a slide on the back, and I can give you guys some websites where you can get some of the documentation, such as the PDF that IBM has out there and stuff like that.
Yep, thank you so much. Like open software, it's very efficient software because they're open and you don't have to pay for it. This is one of the cons for that. So, but the other side from it that it will be, it's not sometimes it will be very well maintained because people are interested in it, but later on maybe could be drop in the interest and they feel behind. So it's kind of, it has a pros and cons. So, but it's still like, it's good to have a look at it and work in it and understand the concept, and later on either you stick to it if you have the developing skills, so you maintain your own software, or you shift for a different thing. But yeah, it's always open sources. It has its own benefit, but it has other side too.
Correct. Is there any other questions? Well, thank you guys for your time and letting me present today on this.
Thank you so much, San Antonio. It was a great presentation, and like I said, this the board, the BBT will be in the group, for the meetup group, and everybody will have access to it. And if you drop some links to documentation, you will find it also in the meetup group. Thank you so much, and we'll see you next week.
Thank you for
Thank
sharing.
you.
Take care all.